So welcome this morning. My name is Simeon Ehrig, and today I want to talk about unit and integration testing in modularized Julia package ecosystems. This talk is motivated by our real-world Julia package ecosystem QED.jl, who will tell you something about in 2 days. But for today, I want to explain how we solve the challenges of unit and integration testing in our package ecosystem. So in the beginning, I clicked. Focus. Okay. Now? Now it's working. Okay, sorry. Yeah. In the beginning, I want to talk about our development workflow. So we use Git in the background. We have the Git workflow approach. This means we have 2 branches, a master for the releases, a dev branch to collect all the changes. And if you want to contribute new code, we do it by feature branches and open pull requests. And this means typically you start writing your code locally on your system, write also some tests, commit it, push it to GitHub, and open a pull request. And when the pull request is open, automatic testing is starting. And on GitHub, it looks like this. So you can see we have, I don't know, I'm not good. I have to hold it. Which button? Whoa. Okay, the middle button is not working. I have no idea. I'm not good in technique with computer stuff. I have no idea. Okay. Yeah, so typically we have different jobs in GitHub on our pull requests on GitHub. So you can see we have different stuff, for example, also building documentation and formatting and so on. But today we want to focus on integration tests and unit tests. And actually this is our pipeline. So maybe you cannot see it good because of the resolution, but the important points are in the beginning, we do some unit tests, and in the end, we do integration tests. And maybe you already recognize this is not GitHub. We use GitLab. We mirror it to it because we use self-hosted runners like GPU runners and big CPU runners. Small disclaimer about this talk. I will want to present some concepts. The concepts are language independent, so I'm also developing C++, and I copied the idea from there and from other languages. But the implementation is pretty Julia specific. You will see later why. And a really important point is, in general, building up a CI is not a small job. So you can start in an hour, but really cover all the tests and developing takes really a big time. For example, one of our sub-packages, QED.base, has at the moment 8 different jobs, 200 lines of configuration for predefined jobs, and I wrote 2 CI tools in Julia, which has also some tests that we can get sure that they are working. Okay, let's start with unit test. I will explain unit test and integration test at an example. And therefore, we have a small ecosystem. We have package A, and we want to implement a new feature or change a function in package A. And we have a package B, which is using the function from package A. And this is how our package A is looking like. So we have the function foo with 1 argument and a test case, and everything is fine. Now we want to change the code, add a new parameter to foo, a second parameter. Therefore, we need to change our test. And this is actually what is a unit test doing. It checks the functionality of the package itself with its own dependencies. So in this case, we don't use any external dependencies. We could, but this means the CI will execute this test from test.gl and say, okay, foo is working now with the new test case. It do correct calculation and everything is fine. If we talk about dependencies, and this becomes later a little bit more important if I'm talking about integration tests, we distinguish between 2 kinds of dependencies. We have our own dependencies and we have third-party dependencies. Own dependencies are dependencies where we are code owners for our ecosystem. And we do it because we want to, we have the dev branches of the different packages, and we want to have that you can check out and build all the dev branches, and they are working together nearly all the time. So because if we would not care about this and say, okay, the dev branch now from package A is not working for until the release, and then we have to fix it for a release, we had this problem that bugs can stack up until a point it becomes pretty complicated to fix all the bugs. And therefore, it's better to say, okay, we fix bugs and inconsistencies between the package as soon as possible. And therefore, we have this difference between own dependencies and third-party dependencies. Third-party dependencies on other sides are classic stuff like static arrays, where we can simply open issues and pull requests and so on. Okay, and the workflow for a unit test looks like the CI job will clone the source code, set all own dependencies to the dev version, and run the unit test, which we integrated with, which we defined with test.jl. And everything is fine, so it's quite easy. Now let's talk about integration test. And here, this is wording. I heard it yesterday in Chris' talks. He named it downstream test. It is a little bit different from developer to developer. How do you define it? In our case, it means we have package B, and package B is using a function foo from package A. And now we remember we changed the API of foo, so now the function is the function needs 2 parameters, but package B is calling it with only 1 argument, and so it means this code will fail. And this is what an integration test is testing. It checks if the other packages which use our package is still working with our code change. And also an important point is the integration test of package B in the point of view from package A are actually the unit tests of package B itself. So at the end, the CI will simply clone package B and run this test, which you can see on the right side. And I already mentioned it, everything happens in the CI pipeline of package A. So it really, if you change some code in package A, it will trigger the integration tests for the other packages. And therefore, we have the following steps. First, we need to determine which packages are dependent on our package. In our case, we know it's package B. I'll show later the algorithm to determine it for more complex ecosystems. Then we need to generate a CI job for each integration test for each package. Each package will clone each integration CI job will clone the package, set the dependency to our package A to the feature branch, and execute the test therefore. And now I want to talk about how we determine these dependencies. And for to explain this, I use a little bit more complicated ecosystem. I use the QED.jl ecosystem because it makes easier to explain how the algorithm is working. And the first thing what we use is the project Thomas of a Julia project describes all the dependencies, and the project Thomas of the dependencies also describe it. So there we get the dependency graph. And here we have only the dependencies of our own dependencies. So possibly dependencies are not included here for the moment. And for our example, we assume we change something in QED fields. So the algorithm would be start at QED.jl. We can do it because we know each package, each of our own dependencies is a dependency of QED.jl. And so we traverse simply the graph. And first we go to QED base, check QED base is not QED fields, and it has no dependencies, so nothing can happen in QED base. So go to the next, it's QED processes. QED processes is not fields again, but it has dependencies. So the first dependency is QED base. We already know QED base is not a search dependency, and we know there's nothing after it, so it's fine. The next one is QED fields itself. And now we know, okay, we come from QED processes. So this means QED processes uses QED fields, and we mark it for the test. The next, and then QED fields has also dependencies, QED base, okay. And then we go next dependency of QED.jl, and it's QED fields again. So it means we need also to test QED.jl, the 2 packages. Okay, and then for the end, we also need to check events, and it's the same stuff, it points to base. And this is the algorithm how we determine which package we need to test. So you can see now we have to create 2 CI jobs for processes and for the meta package QED.jl. Okay. The other stuff which I want to explain is what happens if the integration test fails, because if the integration test passes, we can simply hit the merge button. So what we have to do is if the integration test fails, and we cannot change the problem itself in package A, we have to modify the dependent package. In our case, we have to extend package B that it can handle the second parameter. So it means we open a new feature branch, develop some code, and open a pull request. And the pull request will automatically trigger the unit test for package B, and it will fail because all unit tests test against the def branch of the other packages. So it means it will test again the def branch of package A, and this def branch requires one argument for foo, but we developed the fix for 2 parameters. So what we can do now, we can set via git commit message that it should use the feature branch of package A, which has this foo with 2 parameters. So I integrated it in the script. It reads it from the git commit message that it should use the feature branch of package A. And then we assume simply integration test passes because package B has no, nobody uses package B. Okay, and then we can do the opposite way. We can say for the integration test, okay, use the feature branch of package B, which solves the problem. And then integration test passes. So package A is working. We have already a solution for package B that later the def branch will also work, and we can merge it for package A. Now, what's about package B? The first thing what is happen is, yeah, we have an extra job which say, okay, this CI will not pass because we don't test or unit test against the def branch of package B. We use a feature branch, which means in practice, if we would merge package B before package A is merged, or def branch becomes instantly broken because we are dependent on a feature branch that is not merged now. But we already merged package A, so it means now in the def branch of package A, there is the foo version with 2 arguments. So we can remove this commit, test against the def branch of package A, unit test passes, and we can merge again. And so package B is also merged. We merged a new feature. We do a RP break. We did a RP break in package A, merged the fix in package B, and the def branches was maybe invalid for minutes. So great. Okay, so what are the lesson learned? So first is implementing or starting testing and automatic testing early as possible. As you postpone it to later, it becomes more and more complicated. Then think about your development workflow. We saw it yesterday in Chris' talk. There are different kinds of testing. Some of the tests are required for your package, something not. Maybe you have special behavior. Develop your CI pipeline incremental. It's like normal development. Don't try to build a cathedral. Do it step by step. And prepare yourself that your CI concept has gaps. So you can think about different problems which could happen, but this is more or less a big complex problem, and you can never thought about every possible problem which can happen. Okay, thank you very much for your attention.